Welcome to Practical AI, everybody. My name's Jeff, and I'm with Peter Lynn. Peter, we had an interesting question come up on LinkedIn, and the prompt was, how can data visualization help you balance accuracy, interpretability, and fairness in ML models? I thought this was a good one for us to kind of discuss today. Help me out. What are your thoughts here?
That's a great question. And the short answer is the tools we have today are kind of horrible, just to be blunt. Because if we look at, let's say, like Amazon or Walmart or Target, a lot of time is spent on trying to visualize just regular business data, right? And that's like typically in the past when we've worked on customer projects, it takes anywhere from 6 to 12 months to get the data together, and then it takes another couple months to create the reports that visualize the data. And even then, it's a lot of trial and error. It's an iterative process of like, hey, your database SQL programmers, I want to see this. So that person goes and does some queries, brings in some data. And then the UI person says, oh, let's try this way, charts or scatter plots or
Tableau.
whatever.
Yeah.
Yeah, or Tableau, and they put it into different tools like Tableau or Power BI or some other tool. They generate it, and then the business user says that looks terrible. Yeah.
So visualization, I mean, this is nothing new. BI or analytics is kind of the new term, and um, everybody wants to draw insights from their data, right? And so, what in the ML space though is lacking where those insights are hard to gather today?
Well, if we do take a step back, the biggest issue is the amount of data is just much bigger, right? Like if you're doing a report for Target, it's like, what are the sales by product category for the last quarter? You might have a million products. Not a big deal. You're Googling, you're training a language model or you're training a computer vision model to recognize stuff. You might have 10 billion pictures. How are you going to visualize that?
Sure. So is it more of a, do you end up more in a statistical view where you're summarizing the math essentially against it and showing a graph and showing shades, heat maps and stuff like that? Is that kind of where this has to go? Because there's so much data you gotta basically turn into statistics.
The short answer is we don't actually know, right? So let's say you're training a model like Google and you've got 10 billion images that you've collected through Google Photos, and people have tagged it with various things like at the beach, at the mountain, at Knott's Berry Farm, or whatever, at the supermarket. So you go through it and you try to look at all those tags. You try to categorize all the images, but at some point you have to like validate. Are those tags correct or are they not correct? Well, then how do you visualize that? Like which labels are correct, which ones are not correct? The ones that aren't correct, can you use a model that you've built to correct all those? Ideally, yes, but sometimes no. And so then how do you visualize that? Of like what percent can you actually fix automatically with a program and which ones you need a human to do? Right.
All right, so if you were able to just sort of dream up your ideal visualization tool, what would it do?
What would it do? I think a general purpose tool to visualize your data actually isn't all that useful.
Okay.
Once you get at scale in the millions and billions and hundreds of billions of pictures, it's actually not useful. What you need to do is you need to look at so I've trained a model to recognize some pictures. And what I need to visualize is in my test data set, how do I compare what's failing and what works? That's what you want to see. Because just generally seeing all of your data is just too much, right? There's too much noise. And what you want is to visualize where it's failing and then be able to like surgically go in there and fix that thing.
Okay, so seeing all of the data is not as important as seeing slices of data or specific data that is either succeeding or failing really well.
Yep.
Okay, so
Exactly.
back to the prompt then. How could data visualization help balance accuracy, interpretability, and fairness?
It could, in that it'll help you to create a data set, the ideal data set, which doesn't exist, but an ideal data set that gets you the most general purpose model that you can. Meaning that it's good at, it's mostly good at the thing you want it to do, and it fails very infrequently. So like maybe the failure rate is only like 1% or 0.1%. Whereas today, if you take YOLO, you take ResNet, you take kind of the common foundational models for computer vision, they all have an average accuracy of like 60%. So it's across all the classes that you've trained on, the average of all the accuracies. Now, some might be like as high as 90, some might be below 50. But on average, if you have 1,000 classes, the average is around 60%, which is basically like, it's not very good.
Yeah. So once you have this visualization capability, then the real benefit would be in creating sort of the general all-purpose model.
Yeah.
And or being able to, in the process of building that, finding the errors, the things that really pop out, and being able to visualize either the actual data elements that failed or the
Yeah.
places in the model that are failing.
Exactly. Yeah. So that's why like Tesla, even though they promised or Elon promised this will be released by 2021, we're in 2024. Well, it's because like they don't know what data is good, what data is bad. But they kept saying we have more data than everyone else. Well, it's like more data doesn't mean anything. And then around 2021, 2022, they said, oh, okay, now there's a button on your screen that you can say, okay, this situation, the full self-driving did it poorly. So it'll log that and then it saves it. So now the humans are helping to figure out what cases it failed. And then they can send that up to the cloud. Then they retrain full self-driving in a simulated environment. But again, like someone has to look at that and go, what was this really truly a good example or not?
Yeah. Yeah, it seems like even the best AI today is using this sort of human in the loop,
Yeah.
At some point, right? Either in training or in
Oh
the
yeah.
data science side or whatever. It seems like there's no vision I see of getting away from that anytime soon.
Not I would doubt it. In the next 10 years, I don't think that's really possible.
Yeah.
Still need.
Well, this is a good topic. Peter, thanks for letting us bend your ear a little bit. Data visualization. Hopefully we get there soon. Thanks, everybody. We'll try to catch up on other good topics here shortly. And be sure to subscribe and comment if you have anything interesting. Take care.